Okay, guys. Today we are going to be talking about solving rational equations. We've already investigated what a rational expression is. It's when you have fractions, both in the numerator and the denominator. When you have polynomials rather than the denominator, it's a rational expression. We had said that a complex fraction is when you have fractions in both in the numerator and the denominator. We learned how to simplify rational expressions. We learned how to multiply, divide, and add and subtract rational expressions. Today we're going to talk about solving rational equations. Okay? A lot of the same kind of concepts. In fact, do you guys remember when we were solving these? Let's say we had 3/5 x plus 1/3 equals whatever, 1/10. Well, for the person who said no, then you better really study for the midterm. We did do this. This was like first quarter. How would we get rid of the denominator here? Yeah, no, not the reciprocal. We'd multiply everything by the LCM, okay? The least common denominator, rather, the LCD. And then from here, this would be 90 over 5, and you could cancel it all out, right? So the goal here was to get rid of the denominator. Yes, sir. Yes, you could have also done that by subtracting, but the whole reason why I showed you this was because today we're going to be eliminating fractions. So I'm just letting you know that we're eliminating denominators. The same procedures are going to be used as when the denominators were just numbers. So a rational equation contains at least one rational expression, at least one. You can simplify solving a rational equation by eliminating the denominators. Okay? You can eliminate the denominators by simply multiplying the LCM of the rational expression to both sides of the equation. Performing these operations can lead to extraneous solutions. We've talked about extraneous solutions before with the absolute values. Extraneous solutions are solutions that do come up, but when you test them, unfortunately, they're not valid. So those are called extraneous. So all our answers must be checked for accuracy. It's not a choice here or, hey guys, you can check to see if it's right. No, you have to check because it may be an extraneous solution. As far as what a rational equation looks like, okay, this is a rational equation. Okay, it has to contain at least one rational expression. And remember that a rational expression is a situation where you have a polynomial in the denominator. Okay, so since you have x plus 1 here in the denominator, and here in the denominator, and here in the denominator you have binomials, that is going to be a rational equation. Now, the one over here is not a rational, because I have fractions, right? But do I have a rational expression here? No, I don't have an x plus 4 in the denominator. I don't have a polynomial in the denominator, okay? So these are the kinds that we're going to be working with today, the actual rational equations. And just again, food for thought. All you got to do here, guys, is just like when we're adding and subtracting, you find the LCD. But this time, what's going to happen is you're going to multiply that LCD to both sides of the equation. And upon doing that, you're going to eliminate the denominators. Now, I know that some of you are looking at me as if I just said something in French. I promise I'm going to make it all come together right now. May I? Okay. For example, have x over x minus 3 plus x over x plus 3 equals 2 over x squared minus 9. First thing you're going to do here always, guys, is factor all denominators. If possible, of course. But all of them. So you can't do much with this. Can't do much with that. But you can factor this to be x plus 3, x minus 3. All right, that should be pretty simple for everyone. Step 2, find the LCD. In this particular case, gentlemen, what's the LCD here? Bless you. X squared minus 9. Okay, yeah, thank you. You're right. Don't put the LCD in that format. Do not go ahead and combine LCDs, because if you put X squared minus 9, will you know what this is missing then? It's not as easy though, okay? So leave it in its factored form. So the LCD is X plus 3, X minus 3. You guys with me? Okay, now, what did I just say? You're going to multiply the LCD to both sides. So literally, you're going to multiply X plus 3 times X minus 3 to both sides. Now please remember the distributive property, guys, and I'm going to show you step by step what's happening here, but eventually you're going to see this in your head. So what's happening here is multiply this to this. So you've got X times X plus 3 over X minus 3 times X minus 3 over X minus 3 plus this guy multiplied to this. X times X plus 3 times X minus 3 over X plus 3 equals, when you multiply this to this, it's going to be 2 times X plus 3 times X minus 3 over X plus 3 X minus 3. I don't do this the long way. That's not because I'm such a awesome math guy. I've just practiced this so much, guys, that I see it. In my head, I know, okay, when I do this first distribution, the X minus 3 is gone, and I'm going to have to distribute X times X plus 3. See what I'm saying? Because this guy cancels out with this, right? So this will be left with X squared plus 3X. You with me? Plus, cancel, X squared minus 3X. You with me, my brothers? Equals, thank you, equals 2. Does everyone see that so far? I'm going to stop right there for a second. Yes, sir, my brother. Well, no. Let's rephrase what you just said. You have to do it the way I did it here. But it's just a matter of, can you do that in your head, or do you have to show it out? But what you're doing here, you're either doing it on paper or in your head. But you got to do it. This is the procedure. Now, if you can do this in your head, brother, God bless you. Yes. No, you cannot do that. Oh, I see. No. Okay, what he's saying is this, guys. Can you just multiply to this one an X plus 3, and to this one an X minus 3, and then to this one an X plus 3, and an X minus 3? Why would you want to complicate your life? Why don't you just distribute and cancel it out? Because you're doing the same thing, sir. But you are canceling out regardless. I said you did not have to write it. And that's what I had just answered. So anyways, I have 3x and negative 3x, they cancel. So I got 2x squared equals 2 divided by 2. X squared equals 1. And then now, how do you cancel out a power of 2? What's the opposite of a power of 2? Square root. So you take the square root. Nope. X equals plus or minus 1. Because what's the square root of 1? Plus or minus 1. What's 1 times 1? And what's negative 1 times negative 1? Exactly. So every square root has 2 roots, a positive and a negative. Now you do have to test this, guys. When x is 1, let's see. I'm going to have 1 over 1 minus, so that's negative 1/2. Plus 1/4. And then 2/8. Yeah, that's going to work. Because I'm going to have here, yeah, this is what's going to happen here. I'm going to have 1 over negative 2 plus 1/4. And that's going to be 2 over negative 8. So this goes to 4. That goes to 2. So that's negative 1/4. And that does equal negative 1/4. So positive 1 works. And then does negative 1 work? Let's find out. This is a negative 1 over negative 4. So that's a 1/4. And then negative 1, and then negative 1 plus 3 is over 2. So that's minus 1/2. And then this is going to be 2 over, it'd still be negative 2/8. This is still going to work. Because, oh wait. No, that goes to 2. Yeah, it works. That's negative 1/4, which equals negative 1/4. So yes, they both work in that case. Yes, sir.
Are we allowed to plug it into x squared plus 3x plus x squared plus 3x?
No. You got to plug it into the original. Okay? Now look, the reason why you plug it into the original, let's say that x was 3. Would that be a solution? Guys, right off the bat, can you have a 3 here? What's 3 minus 3? So that's undefined, so you cannot have that. Does that make sense? All right, let's do another one. Let's do it now. Yes, sir. The solution is right here, Chief. Thank you, son. Okay, now, first step, let's factor these bad boys. So this is x minus 1 over x plus 2, x plus 1. Thank you. Good job, guys. And then 2x over just x plus 2. And then equals x minus 1 over x plus 1. What's the LCD here, my brothers? X plus 2 and x plus 1. Okay, so I'm going to multiply to both sides of the equation the LCD. And this time I'm going to do it in my head, okay? So that all of you can see that you can do it in your head. I'm going to show you how I manipulate this in my head. I'm going to walk you through it verbally. So this is what I do in my head. I know, okay, and this one's easy. These are going to cancel, right? Hello? Did you see that, guys? Guys, did you see that? Right, so here I'm just left with x minus 1. Done. Now I'm going to multiply it over here, right? Which one of these is going to cancel? The x plus 2. So what am I going to distribute the 2x to? 2x plus 1. So this is going to be 2x squared plus 2x. And then over here, when I multiply this to that, who gets canceled? X plus 1. So now I got to do x minus 1 times x plus 2. Remember that x minus 1 times x plus 2, I got a FOIL. So x times x is x squared plus 2x minus x, that's plus x, minus 2. Now, let's go ahead and simplify. This is going to be 2x squared plus 3x minus 1 equals x squared plus x minus 2. So go ahead and subtract x squared to both sides. I got x squared, subtract the x, plus 2x, add the 2. That's plus 1 equals 0. We know how to solve by factoring. X plus 1 times x plus 1, because 1 times 1 equals 1, and 1 plus 1 is 2. So x equals negative 1. And then, it is what it is. We have to check this. Will negative 1 be a solution here right off the bat? Look at the denominators. Look right here, guys. X minus 1 over negative 1 plus 1? No, that'd be 0. So this, extraneous. You got to do it all, and then at the end you would say, look, yeah, this is extraneous. Because it is a solution. It's just not going to work. Sir. 0 over 0. Ooh. That's a good question. I'll investigate that, but I think it's still going to be undefined. Because you can't have a 0 in the denominator. Yeah, so. Does that make sense, my brothers? May I continue? Because I got time. We're perfectly good? Everybody? Okay. You sure? Cool? Cool. Thank you. See, I don't know if I still have more on this page. No, the next page. Okay, that's what I thought. All right, now solve the following rational equation. Okay, this one's really easy, right? Except, look at this up here. Do you think it would benefit us to go ahead and, Yes, it would. Okay? Always factor everything you possibly can. X minus 1 over x plus 2 equals x plus 3x minus 1. Thank you very much, gentlemen. And then x plus 2. So I'm going to multiply x plus 2 to both sides. But look, for something like this, it's just so Mickey Mouse in this case. That cancels, so it's x minus 1. That cancels, so it's back to x squared plus 2x minus 3. Subtract the x and add the 1. Subtract the x and add the 1. So I got 0 equals x squared plus x minus 2. So luckily we know how to solve that. It's going to be x plus 2x minus 1. So x can equal negative 2 or positive 1. But unfortunately, we got to check that. It can't be negative 2, but it can be negative 1. So x equals 1 and negative 2 is extraneous. Yes. I promise. Yes, sir. If I see that you did this and you crossed it out, I will understand that you said extraneous. Sir. 0 over 0 is definitely not infinity. No. Okay, we'll talk about 0 over 0 later, guys. Why don't we focus on what we're going to be tested on? Okay? Thank you. Does this make sense, gentlemen? Everyone's got this. All right. Okay, who wants it? Oh, look how I did that. Just for everyone that's out in the internet world, I was looking at someone. They thought they were going to go up, but I psyched them out and gave it to someone else. All right. Do it. Let's see what we got. Psst. Hey. Shh. Okay, he's going right to the kill. He already put the LCD. That's the LCD. And he's going to distribute it. He's doing it his own method, but I know what he's doing. Hopefully you guys see it too. Correct? And the x plus 1 will cancel on that first distribution. Correct, son. Correct, and the x plus 4 would cancel. Good job, son. That's perfect. Perfect. Doing great. Doing great. Take your time. And the x plus 4s would cancel there. But wait, may I? Equal. Hey, guys. Come on. He's human. Correct, my brother. Very good. Here, just so, hold on. Because you're writing pretty large, let me just try to help you out. Let's go ahead and take all of this. Okay. And then let's just group it together for a second. And then let's go ahead and shrink it a little bit. So that way you know what you're doing, okay? And that way you have plenty of time. Does that make sense? Thank you, son. Go ahead, bro. So I want to see what he's got, right? X plus 4 times x plus, in parentheses, x plus 1 times 3 equals x plus 1 times x plus 3. So that's what you guys should have. You should all be doing this. Everyone. Okay, so we got x squared plus 4x and then 3x plus 3. And now he's going to FOIL x squared. Very good, plus 4x plus, perfect, son. Okay, now, correct? 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 Very good, son. Very good. That's exactly right. Good job. Boom. Perfect. And guys, just so you, in case you're wondering, look, it's 0 plus 1 plus 3 over 0 plus 4 equals 0 plus 3 over 0 plus 4. That's 0. 3/4 does equal 3/4. Giddy up. Does it make sense? Yeah? Go for it, my brother. Next one, go. Yeah, you've been working hard. You're always trying hard. Let's do it. Hey, come on, guys. Let's do it. Let's do it. Let's do it. Everyone should be doing these, so that way everyone gets practice, not just the gentleman on the board. All right, let's just pretend that practice is good. Bless you. Very good, son. So far, he's doing great. He's multiplying by the LCD. Yes, sir. Right, so then divide by -3 to both sides, and x equals 0. Come on, man. Get on the train of success. Correct, son. You're doing great. You're doing great. Shh. Let the man concentrate, please. Awesome, dude. And then here, FOIL it. But remember, it's a difference of squares, so if you know it, it'd be really easy. That's my boy. Nice job, kid. Nice job. Yes. 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 Correct. Awesome. Heck yeah. Is that going to work, though, kid? Is that going to work, though? That's the real good. That's the real big question, my brothers. Is that going to work? Yes, it does. You're darn right. Good job, son. Great job. Does that make sense, my brothers? You sure, man? So we're golden. We can quiz? Cause wait, we got till 25 or till 30?
25.
Okay. Do you guys want to just? I'll end my lecture right now. Do you guys want to continue practicing this or quiz it up? Okay. We're done right now. Let me close this out. Thank you, guys. Great lesson.